The past, present, and future of human exploration of extraterrestrial life. Introduction. The quest to explore extraterrestrial life has journeyed through an intricate tapestry of scientific discovery, technological advancement, and evolving public perception. From early conjectures about life beyond Earth to sophisticated missions aimed at uncovering evidence of life on Mars and other celestial bodies, humanity's relationship with the cosmos has deepened significantly. This report outlines the historical context, current endeavors, and future prospects of this exciting field. Historical context. The modern era of extraterrestrial exploration began in earnest in the 1960s and 1970s, marked by a series of robotic missions that ventured into the depths of our solar system. The Viking Landers launched by NASA were among the first attempts to detect life on Mars. Despite their ambitious scientific objectives, the Viking missions returned results that were largely disappointing, failing to find definitive evidence of biological activity. This phase of exploration represented a nadir for the field of exobiology, as the vastness of space seemed to reinforce the belief that Earth might be the only cradle of life. However, the discovery of extremophiles, organisms that thrive in extreme conditions on Earth, revolutionized our understanding of life's potential resilience. These bizarre life forms, capable of surviving in environments previously thought to be inhospitable, suggested the possibility that life could exist in similarly harsh conditions elsewhere in the solar system. This pivotal shift in perspective reignited scientific interest in the search for extraterrestrial life. Present exploration. In recent years, Mars has emerged as the focal point of astrobiological exploration. NASA's Perseverance rover, which landed on the Red Planet in 2020, is specifically designed to search for signs of ancient life and collect rock samples for future return missions. The current objectives focus on identifying areas where liquid water may have existed, as well as searching for biosignatures, indicators of past or present life. Mars is considered a prime candidate for such discoveries due to its geological history, which suggests the presence of liquid water on its surface billions of years ago. The European Space Agency (ESA) is also contributing to this burgeoning field with missions aimed at further exploring Martian geology and potential life. The Mars Express, launched in 2003, has provided invaluable data, while upcoming missions are anticipated to involve sample return protocols and even human exploration by the mid-21st century. Future prospects. As humanity's technological capabilities evolve, the implications of discovering extraterrestrial life become increasingly profound. Research from Arizona State University indicates that public sentiment toward potential encounters with extraterrestrial life is largely optimistic. Historical reactions to past discoveries, such as the claim of fossilized Martian microbes found in a meteorite, reveal a trend where excitement and curiosity overshadow fear. Studies conducted by ASU's psychology department highlight that people generally anticipate positive outcomes from the discovery of extraterrestrial life. For instance, in a pilot study analyzing media coverage of potential life discoveries, participants expressed more positive than negative emotions. This trend suggests a fundamental shift in public perception, moving away from speculative fears of alien encounters toward a more hopeful outlook. Technological and ethical considerations. As we stand on the brink of potentially discovering extraterrestrial life, technological advancements are reshaping the landscape of exploration. Initiatives like ASU's Interplanetary initiative aim to democratize space exploration and prepare humanity for future encounters. These discussions encompass not only the search for life but also the ethical considerations surrounding potential discoveries. How would the confirmation of extraterrestrial life reshape human society? What responsibilities would we have toward newly discovered life forms? Moreover, the efforts toward human missions to Mars necessitate a robust understanding of the Martian environment. NASA's Mars exploration goals include not only searching for signs of life but also preparing for human exploration. This involves studying the potential hazards posed by radiation, the chemical makeup of Martian soil, and the availability of resources like water which could support human life on the planet. Timeline of key events: 1960s to 1970s. Initial robotic missions yield no signs of extraterrestrial life, especially on Mars. 1976. Viking Lander's experiments yield disappointing results, marking a low point in exobiology. 1998. Possible fossilized Martian microbes found in a meteorite rekindles interest in Mars as a candidate for past life. 2003. ESA's Mars Express launched, enhancing the exploration capabilities of the Martian environment. 2020. NASA's Perseverance rover lands on Mars, tasked with searching for ancient life and collecting samples. Future plans for human exploration of Mars and missions to other celestial bodies like Europa are underway. Conclusion: the exploration of extraterrestrial life has transitioned from skepticism to proactive inquiry, especially concerning Mars. The integration of findings from various missions and studies highlights a collective optimism about the potential for life beyond Earth. As humanity prepares for its future in space, both technologically and ethically, the journey to uncover the mysteries of the cosmos continues to captivate and inspire. This report encapsulates the evolution of humanity's exploration of extraterrestrial life, reflecting on historical challenges, current advancements, and future possibilities. As our understanding deepens, the prospect of discovering life beyond Earth remains one of the most profound and intriguing scientific pursuits of our time. The exploration of extraterrestrial life has undergone a significant transformation, evolving from speculative musings to a field rich with scientific inquiry and technological advancements. This journey spans historical setbacks, current missions, and future aspirations, particularly in relation to Mars and other celestial bodies. Historical context: initially, the quest to uncover extraterrestrial life faced substantial hurdles, especially in the 1960s and 1970s. The Viking Lander missions aimed to detect life on Mars but returned negative results, which led to a deep skepticism regarding the existence of life beyond Earth. This disillusionment was compounded by the perceived vast emptiness of the solar system, prompting a belief that Earth might be unique in its ability to support life. However, the discovery of extremophiles, organisms thriving in extreme conditions, shifted this narrative dramatically. These findings suggested that life is more resilient and adaptable than previously thought, opening the door to the possibility of life existing in harsh environments elsewhere in the universe. Present exploration: today, Mars is at the forefront of astrobiology and the search for extraterrestrial life. NASA's Perseverance rover is currently exploring the Martian surface, searching for signs of ancient life and collecting samples to be returned to Earth in the future. The emphasis on identifying liquid water energy sources and potential biosignatures has elevated Mars to a prime candidate for the discovery of extraterrestrial life. The European Space Agency (ESA) is also engaged in Martian exploration, planning missions that may include human landings by the mid-21st century. Interestingly, the current public sentiment towards the possibility of discovering extraterrestrial life has shifted towards optimism. Research from Arizona State University indicates that reactions to past findings, such as claims of microbial fossils in Martian meteorites, have generally been positive rather than fearful. This reflects a fundamental change in how humanity perceives the idea of life beyond Earth, contrasting with earlier anxieties about alien encounters. Future prospects: looking ahead, the potential for human encounters with extraterrestrial life raises numerous questions. Studies suggest a prevailing optimism among the public regarding such discoveries. For example, a study analyzing media coverage of past extraterrestrial life findings revealed a trend toward positive emotional responses. Participants generally expressed excitement about the prospect of discovering alien life, viewing it as an intriguing development rather than a threat. This optimism is a significant counterpoint to previous speculative fears associated with alien life. indicating a cultural shift in how humanity might respond to contact with extraterrestrial entities. Technological and ethical considerations. Advancements in technology are reshaping the landscape of space exploration. Initiatives like ASU's Interplanetary initiative aim to democratize access to space and prepare humanity for future challenges and opportunities. Ethical considerations surrounding the discovery of extraterrestrial life are becoming increasingly relevant as we prepare for potential encounters. Discussions are emerging regarding how such discoveries could impact human society, our understanding of life, and our place in the cosmos. Key discoveries and events timeline. 1960s to 1970s, early robotic missions find no evidence of extraterrestrial life, particularly on Mars. 1976, Viking Lander experiments yield disappointing results, marking a low point for exobiology. 1998, possible fossilized Martian microbes found in a meteorite reignites interest in Mars. 2003, ESA's Mars Express launched to enhance Martian exploration capabilities. 2020, NASA's Perseverance rover lands on Mars to search for ancient life and collect samples. Future, plans for human exploration of Mars and missions to other celestial bodies like Europa are in development. Counterintuitive insights. 1. Shift from skepticism to optimism. The initial skepticism surrounding the existence of extraterrestrial life has transformed into a hopeful outlook supported by public sentiment that is more welcoming than fearful regarding potential discoveries. 2. Resilience of life. The existence of extremophiles on Earth demonstrates that life can thrive in extreme conditions, suggesting that the traditional criteria for life, dependent on liquid water and moderate temperatures, may be too narrow. This broadens the scope for where life could potentially exist in the universe. 3. Future reactions to discovery. Contrary to the fear-based narratives often portrayed in media and culture, empirical studies indicate that humanity is likely to react positively to the discovery of extraterrestrial life, signaling a fundamental shift in societal attitudes. 4. The role of public engagement. The increasing involvement of private entities in space exploration coupled with public interest suggests that the future of space exploration will be shaped not just by government agencies but also by a broader community including citizens and commercial entities. 5. Technological democratization. The drive to democratize space exploration raises ethical questions about access and the implications of human presence in space. Diverging from the traditional view of space as a realm primarily for government-funded missions. This evolution in human exploration of extraterrestrial life reflects a growing sophistication in our understanding of life's potential manifestations and the technologies required to seek it out. As we continue to explore the cosmos, the emphasis on collaboration, ethical considerations, and optimistic engagement will play crucial roles in shaping our future interactions with the universe. The exploration of extraterrestrial life has undergone a dramatic evolution from early speculative efforts to a scientifically rigorous endeavor focusing on astrobiology, primarily centered on Mars and other celestial bodies. While much attention is given to the advancements in current missions, several crucial aspects of this exploration are often overlooked. Yet they are significant in shaping our understanding and future approaches to extraterrestrial life. 1. Historical challenges and the rediscovery of extremophiles. One of the most significant transitions in the field of astrobiology occurred with the realization that life can exist in extreme environments on Earth, known as extremophiles. Early missions in the 1960s and 1970s, such as the Viking Lander, found no evidence of life on Mars, leading to a period of skepticism regarding the likelihood of extraterrestrial life. However, the discovery of extremophiles fundamentally changed this narrative. Significance: the ability of extremophiles to thrive in conditions previously thought inhospitable, e.g., extreme temperatures, acidity, and lack of sunlight, expanded the potential habitats for life beyond Earth. This shift in understanding not only revived interest in Mars but also opened up possibilities for exploring other celestial bodies such as Europa and Enceladus, where subsurface oceans may harbor life. The implications of extremophiles challenge preconceived notions of life's requirements, suggesting that life could exist in a wider array of environments than previously thought. 2. Technological innovations and ethical considerations. The current era of exploration is marked by significant technological advancements that enhance our ability to search for extraterrestrial life. Missions like NASA's Perseverance rover employ sophisticated instruments to detect signs of ancient life and analyze Martian geology. However, as we advance technologically, ethical questions surrounding space exploration and potential contact with extraterrestrial life become increasingly relevant. Significance. The ethical frameworks and discussions that emerge from these explorations are critical, particularly in light of potential discoveries of microbial or intelligent life. How humanity reacts to such discoveries could redefine our understanding of ourselves and our place in the universe. As noted in research from Arizona State University, public sentiment tends to lean toward optimism rather than fear when contemplating contact with extraterrestrial life. This optimism suggests a readiness to embrace such discoveries, but ethical considerations about colonization, contamination, and the rights of discovered lifeforms must also be addressed to ensure responsible exploration. 3. Public perception and psychological responses. The findings from studies examining public reactions to potential discoveries of extraterrestrial life are noteworthy. Research indicates that the general public tends to respond to the prospect of discovering extraterrestrial life with excitement rather than trepidation. For instance, a pilot study analyzed media coverage of significant events related to extraterrestrial life and found predominantly positive emotional responses. Significance. Understanding public perception is crucial for shaping future communication strategies surrounding extraterrestrial discoveries. If the public is generally inclined to view the discovery of life beyond Earth positively, this can facilitate broader support for funding and policy initiatives in space exploration. Moreover, engaging the public in discussions about potential discoveries can foster a more informed citizenry that is better prepared for the implications of such findings. 4. The search for biosignatures and non-Earth-centric life forms. The search for biosignatures, indicators of past or present life on Mars and other celestial bodies, is a central goal of current missions. However, the challenge lies in defining what constitutes a biosignature. Life on other planets may not adhere to Earth's biochemical rules, which complicates our search efforts. Significance. This recognition prompts a need for a broader non-Earth-centric framework for identifying life. As we develop technologies to detect biosignatures, we must remain open to the possibility that extraterrestrial life could be fundamentally different from life as we know it. This paradigm shift in searching for life forms encourages more innovative scientific approaches and increases the likelihood of discovering life in forms that may not fit traditional definitions. 5. Future prospects for human exploration. Looking ahead, plans for human exploration of Mars and beyond raise critical questions about humanity's role in the cosmos. As space agencies like NASA and ESA outline missions for crewed flights to Mars, the implications of human presence on other planets must be considered. Significance. The potential for human exploration of Mars is not just about discovery. It also involves the responsibility of ensuring that human activities do not harm existing ecosystems or microbial life forms. The ongoing dialogue about the ethical implications of colonization and the preservation of extraterrestrial environments is crucial. As humanity ventures further into space, developing a sustainable and ethical framework for exploration will be essential for long-term success and harmony with the cosmos. Conclusion. The exploration of extraterrestrial life encapsulates a rich tapestry of historical challenges, technological advancements, ethical considerations, and evolving public perceptions. As we stand on the brink of potentially groundbreaking discoveries, it is essential not to overlook the significance of each of these elements. They are intertwined, shaping the trajectory of our quest to understand life beyond Earth and our place in the universe. Preparing for the future means not only advancing our technological capabilities but also fostering a responsible, inclusive dialogue about the implications of our discoveries and actions. 1. Historical context and evolution of exobiology. The exploration of extraterrestrial life has transitioned from speculative theories in the 1960s and 1970s, marked by disappointing results from missions like the Viking Lander, to a more optimistic and scientifically grounded approach in astrobiology. The discovery of extremophiles on Earth, organisms that thrive in extreme conditions, has profoundly shifted our understanding of where life might exist in the universe, suggesting that life could potentially flourish in similar harsh environments on other celestial bodies, particularly Mars. 2. Current Mars exploration efforts. Presently, Mars is the focal point of the search for extraterrestrial life. With missions like NASA's Perseverance rover and ESA's planned missions aimed at uncovering signs of ancient life and understanding the planet's geology and climate. NASA's exploration goals include determining whether life ever arose on Mars, identifying conditions that support life, and characterizing the Martian environment. The search for biosignatures and the potential for liquid water are crucial components of these current missions, highlighting Mars as a prime candidate for discovering extraterrestrial organisms. 3. Public perception and potential encounters with extraterrestrial life. Research indicates a significant shift in public perception regarding extraterrestrial life. Studies show that people generally respond positively to discoveries suggesting the existence of life beyond Earth, contrasting with earlier fears of alien encounters. This optimism reflects a growing acceptance of the possibility of finding extraterrestrial life and suggests that humanity may approach such news with curiosity and excitement rather than fear. Highlighting the psychological and social implications of potential contact with alien life forms. 4. Technological and ethical considerations for future exploration. The future of human exploration of space, particularly in relation to extraterrestrial life, raises complex technological and ethical questions. Initiatives like ASU's Interplanetary initiative aim to democratize space exploration and prepare humanity for its potential interactions with alien life. Discussions encompass not only the scientific aspects of the search for life but also the ethical implications of discovering life forms and how these findings might reshape human society. As space exploration becomes more accessible, understanding the responsibilities that come with such discoveries will be critical for the future of human engagement with the cosmos. 1. The Viking Landers. 1976. The Viking program, initiated by NASA, was a series of missions aimed at exploring Mars and searching for extraterrestrial life. The Viking Landers, Viking 1 and Viking 2, conducted various experiments designed to detect biological activity in Martian soil. Despite their sophisticated instruments, both landers returned results that were interpreted as negative for the presence of life. This led to a significant setback in the field of astrobiology. The missions, however, laid the groundwork for future exploration and revived interest in the search for life on Mars, leading to more advanced missions in subsequent decades. 2. The 1996 Mars meteorite ALH-84001. A meteorite ALH-84001 discovered in Antarctica was found to contain structures that some scientists claimed resembled fossilized microbial life. The announcement in 1996 by NASA sparked intense debate and interest in the possibility of past life on Mars. This discovery rejuvenated the field of astrobiology and prompted further inquiry into Martian geology and history. Although later analyses suggested that the structures could be explained by non-biological processes. The event highlighted the potential for life on other planetary bodies and the complexities involved in interpreting scientific data related to extraterrestrial life. 3. The search for exoplanets and the Kepler mission. 2009 to 2018. The Kepler Space Telescope was launched to discover Earth-like planets orbiting other stars in the habitable zone where conditions might be right for life. Over its operational years, Kepler identified thousands of exoplanets, significantly expanding our understanding of the potential for life beyond our solar system. This effort marked a paradigm shift in astrobiology as the search for extraterrestrial life expanded beyond our solar system. igniting public interest and fostering new scientific inquiries into the conditions necessary for life to exist elsewhere in the universe. The discoveries from Kepler have opened avenues for future missions aimed at characterizing the atmospheres of these exoplanets for biosignatures. The exploration of extraterrestrial life has progressed from speculative musings to a serious scientific pursuit, especially in the realms of astrobiology and planetary exploration. The past few decades have witnessed a resurgence in interest in technological advancement, especially focused on Mars and icy moons like Europa. This outlook will explore the potential future of human exploration of extraterrestrial life, encompassing predictions in scientific discoveries, public perception technology, and ethical considerations. Scientific discoveries. 1. Mars as a prime candidate. The future will likely see intensified efforts to explore Mars, particularly with the planned human missions by NASA and other space agencies. By the 2030s, the first human footprints may be planted on Mars, aiming to investigate the ancient riverbeds and sedimentary layers that could harbor biosignatures of past life. The technological advancements in rovers and landers will allow for more sophisticated analysis of Martian soil and atmosphere, potentially leading to groundbreaking discoveries. 2. Jupiter's moon Europa. Europa is considered another significant site for the search for extraterrestrial life due to its subsurface ocean beneath a thick ice shell. Future missions such as NASA's Europa Clipper, scheduled for launch in the 2020s, aim to analyze its ice and ocean composition, looking for chemical signatures that might indicate life. 3. Exoplanet exploration. The search for life will expand beyond our solar system with increasingly sophisticated telescopes capable of characterizing exoplanet atmospheres. Missions like the James Webb Space Telescope will analyze the atmospheres of potentially habitable exoplanets, looking for biosignatures like oxygen, methane, and other indicators of biological activity. Public perception and response. 1. Positive reception to discoveries. Research indicates that public reactions to the discovery of extraterrestrial life are largely optimistic. This trend is likely to continue as humanity becomes more accustomed to the notion of life beyond Earth. If microbial life is discovered on Mars, for example, it could spark excitement rather than fear, leading to a broader acceptance of our place in the universe. 2. Cultural shifts. As discoveries are made, global culture may adapt, integrating the idea of extraterrestrial life into philosophy, religion, and art. This could reshape human identity, prompting us to reconsider our role on Earth and in the cosmos. Technological advancements. 1. Robotic and autonomous exploration. The future of extraterrestrial exploration will likely be dominated by robotic missions, which are more cost-effective and safer than human missions. Advances in artificial intelligence and robotics will enhance the capability of these missions, allowing for more autonomous decision-making and in-situ analyses of environments that may harbor life. 2. Human exploration technologies. For human missions, technologies focusing on life support systems, radiation protection, and in-situ resource utilization like extracting water and oxygen from Martian resources will be critical. The development of habitats that can protect astronauts from harsh conditions on Mars is also essential. 3. Collaborative space efforts. The international collaboration among space agencies such as NASA, ESA, and private enterprises will facilitate shared knowledge and resources, speeding up the exploration process. The democratization of space travel may also lead to innovative partnerships that enable broader participation in exploration efforts. Ethical considerations. 1. Planetary protection. As exploration intensifies, ethical dilemmas regarding planetary protection will arise. The potential for contaminating other worlds with Earth life will necessitate strict guidelines and protocols to ensure that any discoveries are authentic and not the result of human interference. 2. Response to contact. The implications of discovering intelligent extraterrestrial life could be profound. Humanity will need to develop frameworks for dealing with such encounters, balancing scientific curiosity with ethical responsibilities. This includes considering how to communicate with extraterrestrial intelligences should the opportunity arise. 3. Environmental responsibility. As humanity looks to colonize other planets, we must address the environmental impact of such endeavors. Sustainable practices will be critical to ensure that exploration does not replicate the destructive patterns observed on Earth. Conclusion. The future of human exploration of extraterrestrial life is filled with potential discoveries that could fundamentally alter our understanding of life in the universe. As technology advances and public perception shifts towards optimism, the scientific community stands on the brink of potentially groundbreaking findings. However, with these opportunities come responsibilities that must be navigated carefully to ensure that humanity's exploration of the cosmos is conducted ethically and sustainably. The coming decades will undoubtedly be an exciting time for astrobiology in the quest to answer the age-old question: are we alone in the universe?